Hey guys, welcome back. My name is Miss Danielson, and today we're going to look at some more challenging compound and simple interest questions. So if you missed out on our introductory lesson to compound interest or our two previous lessons on simple interest, I'm linking them down in the description box below. Let's get started with a bit of a recap of our formulas. Simple interest versus compound interest. Simple interest, we've got that nice simple formula, I equals PTR over 100. And it shows linear growth. Interest grows linear by a set percentage of the principal value for every single term. So the same amount of interest per each term. And we saw that graphically. Then we looked at compound interest, which had a slightly more complicated formula, but it shows exponential growth. That is, that the total value of the investment grows exponentially. It grows at an increasing rate. Compound interest is often favorable in terms of investments because they grow at an exponential rate. They grow more quickly because we're constantly reinvesting the interest that we earn back into our investment. One of the biggest differences between these two formulas and the biggest mistake that people make is not realizing that the simple interest formula is set out to calculate the total interest earned, whereas the compound interest formula is set out to work out the total value of the investment or loan at the end. So to make these two formulas comparable, either you need to add the principal value to the interest you work out on the simple interest formula, or you need to subtract the principal value from the total amount you get from the compound interest formula. Let's have a look at a couple of examples. So for example 1, Amanda has £500 which she would like to invest for 10 years. Bank A offers her a 2% annual rate of interest to be paid out at the end of 10 years. Now I'm giving you a hint here by saying simple interest, but if they had just worded it like that without saying simple and without saying compound, we need to know that that means simple interest. Bank B offers her a 1.5% rate which is compounded annually. Okay, so compounded must mean it's compound interest. Which bank should Amanda invest her money with? Let's start by looking at Bank A's offer. Whether it's simple interest or compound interest, we always have to start by identifying our variables. So we know P is our principal amount, and Amanda wants to invest between these two formulas and the biggest mistake people often make. We know T is that the simple interest time that she's investing for, or the number of terms, while the compound interest 10 years works out the total. And we know what R is. That's the rate of interest that the bank's willing to make these values comparable. You now, knowing that need to find the total value, I, the interest, at the end of a simple interest investment or loan by adding the interest to the principal amount. I equals P, which is 500, for compound interest, which is 10, find the total R interest earned over 100, the principal, which would give us £100 interest. Bank B, which offers the 1.5% of interest, which is compounded annually, is compound interest. But we still start by identifying our variables, and most of those variables are the same. The principal, the amount that she wants to invest, is the same. She still is investing £500. The time is still the same. She's investing her money for 10 years, but the rate is now 1.5. Now the compound interest formula, remember, works out the total amount she will have at the end of the maturity of her investment. So the total amount will be equal to the principal amount, which has been increased repeatedly by 1.5%. That is, we're going to be finding 101.5% of the principal amount and repeatedly increasing by that amount. So although this may look a bit confusing to you, it's an oversimplification of what we started with. Remember, we're increasing 500 by the 1.5%. That's finding 100 plus 1.5% of the 500. Well, 100 plus 1.5% would be 101.5%, which I could write simply as a decimal by dividing the percentage by 100 is 1.015. That makes setting up your formula a lot easier when you can do this step mentally. So I'm increasing 500 by 1.5% repeatedly 10 times. So I'm multiplying 500 by 1.015 to the power of 10. That's going to be £580 and 27 pence. Now this value has been rounded to 2 decimal places, which is the general expectation for money. It should always be rounded to 2 decimal places, regardless of the currency. That's generally what's expected. So now, which bank should Amanda invest her money with? Be careful with this. I know what you're thinking. You're looking at option A, £100, and option B, £580 and 27 pence. But be careful because option B is the total amount she will have at the maturity of her investment, whereas option A is just how much interest she has earned. So thinking about that, her investment would be worth 500 plus the 100 interest, which is £600 at maturity with Bank A. So Bank A gives her a greater final amount of £600, whereas Bank B only gives her £580 and 27 pence at maturity. That's only £80 and 27 pence in interest. So I would say go with Bank A. Let's have a look at another example. Alvaro has €1,200 to invest, and the bank has several fixed-rate guaranteed investment options. Now that was a mouthful, but that's what you're looking for. A fixed rate means that regardless of what happens with inflation or the stock market, you're guaranteed to get this percentage rate of interest. Now, if you're willing to take a gamble, your rate may change. It may go up or it may go down, but with fixed rate, you know what you're getting into. And if it's guaranteed, that ensures that you're going to get your principal back in full. So let's have a look at these different options. Option A offers him a 1.5% annual interest rate, compounded yearly for 10 years. Okay, so that must be compound interest, right? Option B offers 2.2% annual rate of interest, compounded yearly for 7 years. This is a higher rate of interest, but a smaller amount of terms. Option C offers him a 1.5% annual rate of interest compounded monthly for 10 years. This looks a lot like option A, but compounded monthly. How's that going to affect our final value? And option D offers him 5 years at 1.5% annual rate of simple interest, followed by 5 years at a 1.5% annual rate of interest compounded yearly. So D is a mixed interest type problem. Part of it is simple interest, part of it is compound interest. This could be interesting. Let's start by looking at option A. In option A, he has a 1.5% rate of compound interest for 10 years. But the principal amount is the same for all options. He's got €1,200 he wants to invest. The time for option A, the bank is offering this deal for 10 years. And the rate that they're offering is 1.5. Now this is compound interest, so we've got our formula up here at the top. And if you want to use this formula the way it's written, by all means, let's start by doing it that way. But again, I'm hoping we can start simplifying it as we understand what we're doing. So the total is equal to the principal multiplied by 100 plus the rate over 100 to the power of the number of terms. So my principal being 1,200, my rate, which is 1.5, is added to 100 and divided by 100 because we're increasing the principal amount by 1.5% repeatedly 10 times, so to the power of 10. Now simplifying this fraction, that's 101.5 over 100 because it's 101.5%. And that simplifies to 1.015 to the power of 10. Now this is the point that I'd like you to get to because it makes the calculating so straightforward and easy. So that just works out to be €1,392.65. That's been rounded again to 2 decimal places, as will always be the case for money. Option B offers a 2.2% annual rate of interest compounded yearly for 7 years. So again, setting up our variables, we know that the principal is the 1,200. That's what Alvaro has to invest. The time In this case, the bank is offering this deal for 7 years, and the rate that they're offering is 2.2%. Again, this is compound interest. However, I'm going to try and urge you to simplify that formula. So we're going to do the principal amount multiplied by 100 plus the rate. So that's 102.2% repeatedly for 7 years. So I'm going to do the principal amount multiplied by 1.022. That's just 102.2% divided by 100. My decimal's been moved 2 places to the power of 7 because it's 7 years. And that works out directly 1,397 euros and 45 cents. Again, rounded to 2 decimal places. Option C offers again an annual rate of 1.5%, compounded monthly this time though, for 10 years. So let's be very clear when we set up our variables. We know the principal amount is still 1,200 euros. The time is 10 years, but we're compounding monthly, so 10 times 12 to figure out how many months that is. That'll be 120 months. And the rate, which is 1.5% annually, if we're working this out monthly, we're going to divide that by 12. And 1.5 divided by 12 gives us 0.125% monthly. It doesn't seem like very much monthly, but it adds up to be 1.5% annually. So let's set up our compound interest formula again, where our principal amount is being increased by 0.125% repeatedly for 120 different terms. Now that might look a bit confusing, but looking at it carefully, there's my principal amount, and this is the same thing as 100 plus 0.125%. That's an increase by 0.125%, and we're doing that repeatedly for 120 months. So that's my power. Okay, that works out to be 1,394 euros and 7 cents. Again, rounded to 2 decimal places. Option D now. D offers him 5 years at 1.5% simple interest and 5 years at 1.5% compound interest, compounded yearly, so back to yearly. Let's first work out our simple interest in the first 5 years. So our principal is 1,200 euros, our time is 5 years, and our rate is 1.5. Setting out our simple interest formula, we're working out how much interest we will earn in those 5 years. So I equals PTR over 100. I equals P, which is 1,200, times T, which is 5, times R, which is 1.5, over 100, and that works out to be 90. That's going to be 90 euros that we earn in that first 5-year period. So by the end of that first 5-year period, we should have 1,200 plus the 90 in interest, that's 1,290 euros. Now this is important because this is the amount that we can now invest in that 1.5% compound interest offer that we have. Right, so setting up our variables again. Now our principal amount is 1,290 because we're starting this second part of our investment with 1,290 euros to invest. The time that we're investing for is another 5 years, and the rate is 1.5%. But this time, we're setting up the formula for compound interest. So we are increasing our 1,290 euros by 1.5% repeatedly for 5 years. That is that we are going to find 101.5% of 1,290 5 times. Okay, so we're multiplying by 1.015. Again, if you're still confused by that, remember this is 101.5%. Written as a decimal, that's 101.5. But to turn a percent into a decimal, we divide by 100. So my decimal has moved 2 places over, which has taken it from between the 1 and the 5 to after the 1. Right, working that out, that gives us a total of 1,389 euros and 69 cents, round to 2 decimal places again. So just having a closer look at our answers now. Option B clearly gave us the highest final amount at maturity, $1,397.45. And that seems to make sense because it had the highest percent of interest. However, we only need to invest our money for 7 years this way, as opposed to 10 in all the other cases. So that makes a big difference. Also interesting was in option A and option C, we've got the same rate of interest and the same amount of time, but look at the difference that it made compounding monthly compared with compounding yearly. And when we compound yearly, that's at the end of the year, we take the interest we've earned and we reinvest it. Whereas compounding monthly, we take the amount that we earn every month and we reinvest it. So we don't wait till the end of the year to reinvest that amount. So our value that we're increasing is growing more rapidly. It's growing monthly rather than yearly. And option D was interesting to see with this mixed interest rate, where first it was simple and then it was compound. And comparing that to option A with the same rate of interest, but compound for the full 10 years, you can see that it does make a difference in the end. It's time for some practice now. Okay, first be very careful with the wording. You need to make sure that you're clear on whether this is simple interest or compound interest. If they don't make it clear that it's compound interest, that generally means it's simple interest. You also have to be careful to read to see if you're looking for the amount of interest or the total amount at the end of the investment at maturity. Okay, question 1. Sean has invested £13,500 at a 5% annual rate of interest for 3 years. Does it say it's compounded or not? I don't see the word compounded. There's your hint. How much will Sean have after 3 years? How much will he have? Will he just have the interest or will he have the total amount? Question 2. Haley invested $10,000 into a compound interest account paying 9.5% PA, that's per annum per year, for 4 years. How much interest will Haley earn? Now be careful, is this compound interest or simple interest? And when you work out your amount, is that the total amount or is that the interest amount? We want to know how much interest she earned. Question 3. Debbie has inherited 15,000 euros on her 18th birthday. She wants to invest the money until she is 21. So be careful with the amount of time that she's investing it for. From her 18th birthday until she's 21. How long is that? Debbie has researched 2 different investment options and their details are outlined below. Option A offers a 6.7% annual rate of interest. Is that simple or compound? And option B offers a 6.5% rate of interest compounded yearly. I think I know what kind of interest that second one is. Which account is the best option for Debbie's inheritance? Okay, so hit pause, give that a go, and when you're ready, we'll take up the answers. I hope you had a chance to hit pause. Here come your answers. For question 1, after 3 years, Sean will have £15,627.94 in total. Question 2, Haley will earn $4,376.61 in interest. So this is on top of the 10,000 euros she started with. If you said that she would have $14,376.61, you worked out the total, not the interest. Option A would give Debbie 3,015 euros in interest, 18,015 euros in total. Because option A was simple interest, your formula would have given you the interest amount, and you need to add the principal to that to get the total amount. Option B, because that was a compound interest, your formula would have worked out the total amount at the end of the investment. So that's 18,119 and 24 cents. Which account is the best option for Debbie? Well, I would definitely go for the higher one, which is option B. Option B, the compounded interest, will earn her about €104.24 more than option A. How are we doing so far? If you find you're struggling, you may want to check in with me before you go on. But if you're ready for it, let's go into a few challenging questions. So question 4. For the last 2 years, Thomas has been investing £7,800 in a 5.2% PA, that's per annum, interest account, which compounds yearly. So compound interest, 2 years, rate of interest 5.25%, and principal 7,800. At maturity of this first investment, he found another account that will pay 6.75% PA for a minimum investment of 3 years. Okay, the second part of this investment doesn't mention compound, so that must be simple interest. So first we need to work out how much he will have at the end of the first 2 years. So compound interest, P is 7,800, T is 2 years, R is 5.25%. Once you've got your final amount at the end of those first 2 years, we'll reinvest that into simple interest where P is the value you just worked out, T is 3 years, and R is 6.75%. How much will Thomas receive at maturity of these two investments? That's B. How much interest will Thomas have earned? Well, this is how much he's earned on top of his principal amount. His principal amount was the 7,800. That's what he started with. So we need to deduct that from the total amount he has at the end to see how much he actually earned in interest. C, by what percent has his invested amount increased? So once you've worked out how much interest he's actually earned, what percent is that more than what he started with? I'll give you a bit of a hint if you need it later. Question 5. Gail wishes to buy a new car. She has saved $10,000, but the car she wants is $12,500. Her father told her that she should invest her money for the next 6 months to earn extra money. The bank will offer her 7.9% per annum, that's per year, compounding monthly. Will Gail have enough money to purchase her car in 6 months' time? Now, just a little bit of real-world advice here. We generally don't invest our money in safe investments like this in order to earn money. Although the bank is offering a very high rate of interest, we wouldn't generally see 7.9% interest these days, certainly not compounding monthly. It's generally not the way we earn money. If I was her father, I would probably tell her to save your money. If you can invest it so it doesn't lose value, do that, but you're also going to need to get another job. Right, let's work this out. Hit pause, give it a go. When you're ready, let's go over the answers. I hope you had a chance to hit pause. Here come your answers. So for part A, how much will Thomas receive at maturity at the end of this investment? He'll have £10,510.96. That's in total. How much interest would that have been? If we take away the principal amount that he invested, the 7,800, we'll see that the actual interest earned was £2,710.96. That's quite a lot of interest. These are very high percent interest rates. We don't see these very often, so don't be surprised in the real world. Miss Danielson did not lie to you. These are just examples. Question C, by what percent has his invested amount increased? If you were struggling with this, let me give you that hint. Percent profit, so the percent that it's increased by, is always worked out by finding the total amount at the end minus the amount you started with, and write that as a fraction over the starting value. So in this case, the amount at the end was 10,510.96. The starting amount was the 7,800. And we need to work out that fraction as a decimal, multiply it by 100 to make it a percentage. And that percentage value was 35%. Finally, will Gail be able to buy her car in 6 months' time? Now, if you were struggling with this one, here's a little hint, so maybe this will help you. 7.9% per annum would be 0.6583% per month. I just divided by 12 for that. So how much does she have at the end of the 6 months? She'll have $10,401.56. So no, she won't earn enough just off interest alone to buy her car. However, over the 6-month period, she did earn some money on this investment, which means that her money has not depreciated. So if the value of the car has gone up over time, at least she hasn't fallen behind with that inflation. I hope you found this topic interesting, and I hope my lesson and exercises have been helpful for you. If I've left anything a bit unclear, please feel free to leave me a comment so I can try and clarify that for you. Otherwise, keep practicing, and I'll see you next time.